How are you? Today's lesson is going to be volume of a sphere. The sphere is the last three-dimensional shape that we're going to discuss the volume of. So I guess it is only appropriate to first start with the definition of a sphere. So a sphere is defined as a round, solid figure in which every point on its surface is going to be equidistant from its center. So essentially saying that no matter where I go around a sphere, if I go from the center outside, center, outside, and I keep on going center, outside, all around the sphere in all directions, all those points connected is going to form that sphere. Now, like a circle, the radius of a sphere goes from the center to any point on the outside of a sphere. So here we have a radius, we have a radius going up, the radius going back, forward, so on and so forth. All the radii of the same sphere are going to obviously be equal. So what comes after discussing what a sphere is the volume formula. There is a derivation of the sphere. I will post that link separate. You don't need to know the derivation. It is interesting. It deals with a cone and how does a cone relate to a sphere, so on and so forth. But what you need to know that the volume of a sphere is 4/3 pi r cubed. So the common error with the volume of a sphere is we often forget that it's pi r cubed. And since so many of our formulas deals with pi r squared, a lot of times by nature we automatically do r squared, but it is r cubed. And the volume formula does have 4/3, an improper fraction, to start. In addition, it's only appropriate now to discuss a hemisphere. A hemisphere is half of a sphere. So if we take our volume formula and we divide it by 2, that's the volume formula for a hemisphere. So like a hemisphere would be like this top portion of the sphere. Okay? So now we can jump right into some application questions. Here's the first one. Randy's basketball is in the shape of a sphere with a maximum circumference of 29.5 inches. Determine and state the volume of the basketball to the nearest cubic inch. So they're taking two separate ideas and combining them together in one question. First, we know it's 3D, so we have a sphere. Now, when we're talking about the circumference of a sphere, it's really the circumference of the circle. So the maximum circumference is going to go right through the center. So I know circumference is two formulas, either pi d or 2 pi r. I'm choosing 2 pi r because the radius is needed for the volume of a sphere. Okay, so the circumference is 29.5 inches. We have to now relate that to volume. So what are we going to do? So we're going to take our circumference information, and I'm going to write down over here. We have the circumference, which is 2 pi r. It is 29.5. And now 29.5 equals 2 pi r. Divide both sides by 2 pi, and we get that the radius is approximately 4.6951 inches. Now I'm going all the way out because at the very end we're using the nearest cubic inch, so I want to go a bunch of decimal places after the whole number. So that I have my radius, I'm going to write down my volume formula and just substitute in. So we know that volume is 4/3 pi r cubed. So I do my r cubed. I put everything into my calculator because I'm rounding to the nearest cubic inch, not leaving it in terms of pi. And we have approximately 434 cubic inches. Okay. The next one we have is a hemisphere. Hold on one second. Sorry about that. I just had to go help my daughter. So we have to find the volume of a hemisphere that has a diameter of 12.6 centimeters, and we have to round that to the nearest tenth of a cubic centimeter. So remember, a hemisphere is half of a sphere. They're giving us the diameter. We know in the volume formula for a hemisphere or a sphere, it's the radius that we need. So let's take a look at what we did first. Looks like we wrote down our formula. We have the diameter, divided it by 2 to get the radius. And now we're going to take our radius and substitute it in for r. Once we do that, notice this little note I made over here. It's really important at this point that you're using your calculator correctly. That alpha y equals function gives you that fraction. You could actually input a fraction within a fraction. So after you do alpha y equals, you kind of have the two boxes on top of each other. In the top, you could actually do alpha y equals again to get another fraction. It really makes just all these formulas and equations very easy to evaluate if you're using that alpha y equals. Anyway, so with all my information substituted in, put this right into my calculator. I'm rounding to the nearest tenth, so that's one decimal place out. So the 9 tells the 6 to go up 1, so we have 523.7 cubic centimeters, which would be choice 1. Okay. On the back, next page, we just have some statements. So first, the cross section of a sphere is a circle. So think about taking a basketball and almost slicing a basketball. The slice of that basketball would be just a two-dimensional circle. So cross section does mean if you slice something, what two-dimensional shape do you get? You can kind of see it here. If this is like your cross section, if this is how you're slicing it, you get this circle right here. What's interesting is the great circle or the greatest circle within a sphere will always intersect the sphere through the center. So you're always going to get the biggest circle of any sphere when you cut it through the center. So with that, it actually brings us to this thought here. How do you think you could get two equal slices from a tomato? And again, assuming that this tomato is perfect spherical tomato. Give you a second trying to think about it. I like this question because if you can think in terms of slicing a tomato, it makes it really easy in terms of just a general sphere for geometry. And I think about my husband when I make him sandwiches, and now that we're home a lot, we often have like cold cuts on a roll, and I'm making cutting the tomato up to put on the sandwich, and he's always like, that tomato is so much bigger than this one, the slices or whatever. And I'm like, all right, so then if you think about it, how would you get them equal? After slicing a tomato, how do you find the sizes of the slices that are equal? And the answer comes from how you slice it. So this is the center of the tomato, right? And I cut. This is going to give me the greatest cut. But as I start cutting equidistant away, these slices would be equal, here and here. If I cut again, equidistant away, so like here and here. Now this slice and this slice are equal. So really you're cutting equal distances from the center on both sides. So that's how you would get, think about like here, if I'm going to cut like this slice, this thin slice, and like this thin slice here. Right now the slices on the end are approximately equal. So you could always bring real life into also our class. So this brings us to this point here. If two planes, essentially two cuts, are equidistant from the center of a sphere, this one here, the intersection and the intersection of the sphere, then the two circles are congruent. So it's like your equal tomato slices. Okay. This really finishes up everything we're going to deal with in terms of a sphere. But on the next page of your PDF, we had some real-life application questions. I thought these questions were important to kind of go over because in terms of your next test, or I should say your first test, you may have an application question or two. So again, just some key things that I want to point out. So the first one says the volume of a rectangular pool is 1,920 cubic meters. Its length, width, and depth are in the ratio of 5 to 2 to 1. Find the number of meters in each of the three dimensions of the pool. So first, we know it's a volume question, and it's the volume of a rectangular prism because it's a rectangular pool. They're telling you the volume is 1,920 cubic meters. And then they're giving you a ratio. And if you think back to ratios, we would always say, what does a ratio mean to do? And so many of you would say, put X. And that's correct. So basically, what do we have? The length is 15x, the width is 2x, and the depth is 1x. Almost think of like base times the height of the prism. So here's my formula. And think about the length. Oops, sorry, I don't know what's happening. I don't like when this happens. So you have the length, the width, and the depth. 15x, 2x, and 1x. It has to equal the volume, which is 1,920 cubic meters. I kind of showed you over here what we did. So when you multiply 15 times 2 times 1 is 30, x times x times x is actually x cubed. So you want to get x by itself, divide by 30, and x cubed equals 64. Now we need to take the cubed root. This is different than taking the square root. So if you want to get to the cubed root in your calculator, you're going to hit math and go down to choice 4. That's the cubed root. Essentially, what number times itself again would give me 64. And the cubed root of 64 is 4. 4 times 4 times 4 gives me 64. So now that I know what x is, I need the 3 dimensions. So it's 15 times 4, 2 times 4, and 1 times 4. So we have 60 meters is the length, 8 meters is the width, and 4 meters is the depth. Okay, so that's number 1.
Mommy.
Number 2.
Why is he needs to stay?
Okay, Mommy's doing her lesson, so go play. Sorry. Okay, so number 2. Ian needs to replace 2 concrete sections in his sidewalk as modeled below. Each section is 36 inches by 36 inches and 4 inches deep. He can mix his own concrete for $3.25 per cubic foot. How much money will it cost Ian to replace the 2 concrete sections? So first and foremost, why I chose this question is because of the units that they're using. Take a look at this. They're giving you the dimensions in terms of inches, but then saying he can mix his own concrete, and they're turning that unit to feet now. So you have to just make sure and be aware in all of these questions that when you're dealing with the dimensions and maybe another in terms of buying something or how many gallons, so on and so forth, that all of the units are the same. If they're not, you have to convert them. So I find it easier to say, okay, well, let's take inches and turn them into feet because we should know that there are 12 inches in 1 foot. So take a look at how we do that. 1 foot has 12 inches. One of the sections is 36 inches. So I know if it is 36 inches, how many feet is that? That's my x. So you can create proportions like this to help convert inches into feet. And when we do that, we cross multiply, we divide, and we find that 36 inches is actually 3 feet. So notice wherever I see 36 inches, I crossed it out and I put 3 feet. Then I have 4 inches. So I set up the same sort of proportion. 1 foot is 12 inches. I have 4 inches. How many feet? Again, cross multiply, divide. You get that repeating decimal, of its rational decimal of 0.333333, so on and so forth, which is 1/3. So that's 1/3 of a foot. Okay, so now I have to figure out, well, what's the volume of this here? So I forgot to do an extra step here. So we have 3 by 3 by 1/3. So that's the volume. So this here is 3 cubic feet. But we also have 3 cubic feet over here. It says here replace 2 concrete sections. So I'm happy I'm actually redoing this again. So we know if we have 3 cubic feet and it's $3.25 per 1 cubic foot, that would then give us $9.75. But there are 2 of them. So let's add to this. And we know it should be 2 times 975. So the total is actually going to be $19.50. $19.50. Okay. So then that is Ian's total cost to replace both of those concrete slabs. Sorry about that. I'm happy I'm talking through this and recognizing, well, hey, I made a mistake. Okay, so we have $19.50 there. Again, key thing to take out from this is you have to make sure you're converting. If it says inches and it says feet here, there's a problem. Okay. The other really important piece, and I'm happy I'm looking up here at my note, is anytime you see this term, per, P-E-R. So whether it's $1.99 per pound for, I don't know, bananas, or $4.99 per pound for American cheese, whatever the case may be, per means to multiply. So whatever you're dealing with, you're going to multiply by this number that's given. So since we knew our volume was essentially 3 cubic feet, we multiplied it by 325. Look down here. Okay, so that's another key thing to take away. And then the last real world application that I kind of liked for this was this here. And it says a child-sized swimming pool can be modeled by a cylinder. The pool has a diameter of 6.5 feet and a height of 12 inches. So right off the bat, they're already trying to trick you. They're telling you the diameter is in feet, but the height is in inches. Very tricky. The pool is filled with water 2/3 of its height. So now again, the height isn't even the full 12 inches, it's 2/3 of it. You have to determine and state the volume of the water in the pool to the nearest cubic foot. And again, 1 cubic foot equals 7.48 gallons of water. Determine and state to the nearest gallon the number of gallons of water in the pool. So what are we dealing with? Kind of let's review what we have here. We have a cylinder. We have the diameter and the height in 2 different units. The height is also only 2/3 of what's given. And we know that we have to find how many gallons we need if 1 cubic foot is 7.48 gallons of water. So take a look at what I have over here. Kind of sketch this out for myself. I knew that the diameter was 6.5 feet. 6.5 feet is 6.5 feet. So I found the radius, because I'm dealing with volume of a cylinder, and the radius is then half of 6.5, which is 3.2. So I filled in 3.2. And then in my head, I know that 12 inches is in fact 1 foot. So I put 1 foot here. Okay, so I fill that in. But it's only filled 2/3 of the way. So it's only 2/3 of the 1 foot. So the height is really 2/3 of a foot. The volume formula now is pi r squared times the height. I have my radius and I have my height. Again, it doesn't say in terms of pi, so feel free to put this all in your calculator, which I did. So here's the volume of the cylinder filled 2/3 of the way. Now, 1 cubic foot, and I have 22.12205 of them, is 7.48 gallons of water. So what am I going to do? Well, I know that if 1 cubic foot is 7.48 gallons of water, and I have 22.12205 cubic feet, I'm going to multiply them. And I get approximately 165 gallons of water. Okay, and again, I'm rounding to nearest gallon, nearest whole number. And that completes that. Okay, so these are your real world application questions. They're a little more challenging. So on your first test, I'm not going to put a ton of them, but you can expect to see probably 2 of them would be fair. And really what I'm kind of pointing out to you right now is you have to be careful of the units. They should always be in the same unit. In addition, that term per means to multiply. And ratios always mean to put your x next to each piece of the ratio, okay? Number 2, we did have to fix because we know that the final answer is 19.5 since there are 2 concrete sections, so please make sure that you have $19.50 there. Okay, so this finishes up a sphere and the real world application questions.